Here's a quick whirlwind overview of the spectrogram tilde external for Macs. Spectrogram tilde is a spectrogram analyzer and viewer UI object that is similar to the waveform tilde external, except that instead of the time domain signal, it's showing the frequency domain representation of the signal. It links to a buffer tilde in the same way that waveform and groove tilde and other objects do. And for this video, I'm just going to kind of blast through a bunch of different features, and then I'll have another video where I demonstrate how to use it for playback and experimentation and so on. So first thing to know is the buffer name attribute. This is the namespace of the buffer you want to link to. So I have specbuff is this one. I've listed that here. If I remove that, it's going to link to nothing. So let me add it back in. And each of the tabs in the help patch that I'm showing here are linked to a different buffer tilde, for example. So we've got spec buff stereo and so on. So you can link to a buffer. When the buffer contents change, if they change through some other object, you're going to get updates here visually in the external. The buffer channel by default will be actually 1. This tab of the help patch should show the default values. I think maybe buffer channel is the one exception to that. By the way, everything that I'm going to mention very briefly here is all documented in the help patch and also documented with more pros in the reference XML file here. So we've got the buffer channel, which let me just demonstrate that really quick. The last tab, multi-channel tab, which we'll come back to, has a stereo file, a stereo buffer, and I'm showing the left channel, channel 1, and the right channel, channel 2 on the top and the bottom. If I were to set this to 0, it would do a mono mix down of the left and the right. So left channel, right channel, mix down, so on. Okay, so I think by default in this tab I'd set it to 0. It doesn't really matter here. This is a mono buffer. Window type is the type of window that's used in the FFT, the forward FFT, to generate the spectral magnitudes that are represented visually here. So in the spectrogram, we've got time on the x-axis and frequency on the y-axis, time from left to right in milliseconds, frequency in hertz from bottom to top. We'll get to how this gets skewed by and scaled in different ways in a second. And in that process of doing the FFT analysis, you can define different windows, just like you can for the PFFT object and other things. The default's Han, just like in Macs. We can specify other ones, and it'll change the look a little bit here and there. For those of you that are experts at spectral analysis, you might have a need for different windows. The window size is the size of the FFT window that's considered the number of samples. The number of useful bins will be half that. So a window of 2,048 samples is going to give us 1,024 bins from bottom to top of magnitudes. Magnitude and phase, but we're looking at magnitude here. The magnitude is represented in decibels, which is common for a spectrogram. And I'm going to skip ZeroPad for a second. The overlap is the amount that those windows overlap, the percentage of overlap. So a 2 times overlap means that the 240,048 sample window, we're doing a window of analysis, and then 1,024 samples later, we're doing another one. So there's a 50% overlap. And you can get more time, you can have a larger window, and you can get more time resolution by doing overlaps. So I have a window overlap of 2, which isn't so great for small files here. You can see this is really a visual thing. It doesn't look great, but I can set this to 8, and you'll see that it refines in the time domain more. And that might be preferable. Just be careful with very large large buffers or maybe high sample rates. Combination of window size and overlap means it has to do more work. So I just defaulted to 2 in the object, and you can increase it for your needs. The ZeroPad is a way of not getting more resolution, but interpolating the frequency resolution for smaller windows, essentially. So if I want a lot of time resolutions, let's say I take a small window of 64 samples. Now I've got 32 bins of frequency resolution. You can see it's not very good. So what I can do is, you can see actually each of the bins, especially with this scale. if I increase the zero padding, let's say I've got a zero pad factor of 8, it starts to interpolate between the bins and smooths it out. There's a point at which there's diminishing returns, like the difference between 8 and 16 doesn't really do anything here. So there might be situations where you want a lot of time resolution, you're zoomed way in, you're looking at some features, and you want to just make it look better and interpolate the bins on the y-axis. That's what zero padding is for. There's a limit to the window size. I have it in the documentation, and it is 32,768 samples. That's arbitrary. I could make it larger if I wanted to. I prevent exceeding that window size. When you combine the size of the window multiplied by the zero pad, you can't come up with a combination that will exceed that size. So this will let me, how many overlaps? Yeah, it'll let me overlap by 64. Let's go back up to 2048. And you could see that it actually updated and it downgraded the zero pad factor to something that allowed it to stay within the legal window size. So zero pad doesn't do too much here. You could see 16, 1, not so much. If we were zoomed way in, it might matter. So window type, window size, zero pad, overlap. Overlap is nice. Let's set it to 8. That's probably more useful for most of what you're going to want. Magnitude scale just defines how the frequency is mapped vertically. So the default is MEL spectrum. Linear is just a linear mapping of frequency, which doesn't represent perceptually how we hear so well, but it might be useful. Then we've got MEL, logarithmic, Bark scale, and ERB, which is equivalent rectangular bandwidth, which is similar to Bark scale, but just a little different in the low frequencies. So just different ways of skewing visually for visual resolution of mapping visually to the y-axis. The color scheme, by default, I have a custom color scheme. We'll get to that in a second, where you can change these colors. I also have Rosius, which is based on the Rosius color scheme in Audacity. Classic, you can't change these, it's just hard-coded, also from Audacity. Grayscale, and then I have inverted versions of all of those. So here's custom, and it'll do an inverted version of that. What are we looking at? Let's go back to custom. The dark colors here represent the lowest magnitude, the smallest magnitudes, and the bright colors, in this case white, we don't see white, represents the highest magnitudes. Let me just show you some of the inversion ones, and then we'll go back to custom. So how we map the cold to hot, or low to high magnitudes to colors, will depend on our mag min and mag max attributes. I have it defaulted to -100 dB and 0 dB. That means that a magnitude of 0 will map to the hottest color in the spectrum, which is white, and a magnitude of -100 will map to black. And anything below -100 is going to clamp to black, and everything above 0 is going to clamp to white. So in this file doesn't get to 0 dB in spectral magnitude. So let me lower this max mag to -20, and now we can see that this energy down here is now white. So I can change how this stuff is mapped to normalize within the range. If I decrease this to -80, we can see that now more of the quiet, the soft magnitudes and the high frequencies have been clamped at black. So we can change that mapping, and it's going to work across any of these schemes. All right, so, but again, I defaulted -100, which is 0 and -100, which is nice to begin with. Mouse modes. So there's 2 mouse modes for interaction, select and move. I also have a way, a little abstraction here that's just a modification of the waveform tilde abstraction that lets you change these different modes. Select mode lets you select in a region of in time and frequency, and you can see that here. By the way, out of the outlets modeled on the waveform tilde object, out of the outlets and also controlled in the inlets, you can send messages in. We see the display start and length in milliseconds, the display low and high in hertz, the start selection and stop and end selection in milliseconds, that's this green rectangle, and the low and high selection in hertz. So it shows me, and I can also modify these directly and change the size. I can also change the size of the waveform, what our window is looking at. So this view lets me select a rectangle, which you're going to see updated here. I can then click and drag on any corner to change two sides. I can click on a side to change just one side. I can click in the middle to translate the selection around, and you can see everything dynamically updates. Out of the last outlet, it's telling me, wherever my mouse is, it's telling me the time, the frequency, and the magnitude at that moment in the spectrogram. So it's always going to do that regardless of the mode. So that is with no special modifier keys. I can resize, I can select, I can move. The moving, if I go up against the edge of the waveform, it's going to just start shrinking and clamping the waveform to nothing. So you got to be aware of that. If I shift click while in the middle of the selection, I can drag right and left to enlarge the time selection, and I can drag up and down to enlarge the frequency from the center of the rectangle. So this gives me a nice intuitive way. I can do it asymmetrically by clicking. I can do it symmetrically by shift clicking and dragging in one direction or the other. Move, which is this hand icon, the move mouse mode, is like the waveform tilde external. I drag up and down to zoom in and out from a time perspective. I drag left and right to pan and move through the waveform in time. So this is very similar behavior to the waveform tilde external. Up and down, left and right, moves everything around. If I shift click, I do the opposite. I went up and down to zoom in the time. If I shift click left and right, right zooms in from the center from a frequency on the frequency axis, and up will pan or translate up or down. So they're kind of inversions of each other. So with the shift click and the regular click, you have the ability to zoom in to whatever it is that you want to look at. And I explain all of this in documentation. Also, everything I just showed you is listed here in bullet points on the behavior tab of the help patch. So now let's look at the messages, some of the messages. So if I want to zoom back out, I can click zoom out, and it'll zoom out on both axes. I can also zoom out frequency. Let me zoom back in again with the mouse. I can zoom in 2 dimensions, zoom out in 2 dimensions, zoom in only the frequency, zoom out only the frequency, zoom in the time, zoom out the time, and so on. So I can do that. I can also view all, which will just zoom out entirely. Let's zoom in again. I can view all frequencies, so that'll zoom out just on the y-axis. I can view all time, that'll zoom out just on the x-axis. I can select a window and then click view selected, and that will zoom into that selected window now. I can take a window, let's say whatever window I'm at, and I can select it. I can take whatever window I'm at, and I can select only, I can not modify time, but select the entire frequency range of that window, can select the entire time range of that window, or select none. So that is, in a nutshell, a quick whirlwind tour of the interaction and how you navigate stuff. Let's see, the color is modifiable. All of the everything but custom and custom inverted are fixed. But if you're in the custom mode, you can change the mapping from cold to hot. I have 5 gradations that map to the dB, whatever it is you've mapped, -100 to 0, and so on. So as an example, let me change this color, the second to coldest, and do something like that. Actually, let me make it transparent, and I'll take the bottom and also make that transparent. And now this is blending in with the back of the patch. But you get the idea. Hopefully, we can change any of the colors that you want with this. And in terms of multi-channel linking, I have a link in and link out inlet and outlet, just like the waveform tilde object. The link in is the last inlet. The link out is the second to last outlet, because the last outlet shows the frequency, time, and magnitudes. And they're designed so that you can link different channels of the same buffer, and it will, for example, zoom in and out. And this is similar to how waveform tilde works. So that is a quick overview of all the functionality of the object. For more details, you can look at the documentation, play around with the help patches. I'm going to make another video where I demonstrate using all this stuff.